A drink can looks like one of the simplest things in a store. It's light enough to crush with one hand, thin enough to feel almost fragile, and common enough that most people never stop to look at it. But inside a factory, that thin metal shell has to survive violent shaping, high-speed printing, internal pressure, filling, sealing, stacking, shipping, and finally the pull of a tab. It starts as a flat roll of aluminum, and in a few rapid stages, it becomes a container strong enough to hold a carbonated drink. So how does a flat sheet turn into a finished aluminum can? The journey begins with huge coils of aluminum sheet arriving at the can plant. Each coil is a tightly wound strip of bright metal, wide, heavy, and smooth. A crane lifts the coil onto an uncoiler, where the outer end is pulled forward and fed into the line. Before the metal can be shaped, it needs help sliding through the machines, so a fine layer of lubricant is spread across the surface. The coating is thin, but it matters. The aluminum is about to be punched, pulled, and stretched at high speed, and dry metal would scratch, drag, or tear before the can ever had a shape. The strip now feeds into a cupping press. The press does not cut squares or rectangles. It punches round blanks from the moving sheet, because each disc will become one can body. In the same motion, each flat disc is pushed into a shallow cup. A leftover skeleton of metal with circle-shaped holes cut through it is pulled away and sent back for recycling. Below the press, small aluminum cups drop in rows onto conveyors. At this point, they look too short and too wide to become beverage cans, but this is the first real step from sheet metal to container. Now comes the most important transformation. The shallow cups enter body-making machines where they are redrawn and stretched to the tall can shape. But how does the metal grow taller without tearing apart? The answer is controlled pressure, smooth tooling, and the way the aluminum is forced through a set of precise rings. A punch pushes each cup forward at high speed. First, the cup is redrawn into a narrower shape. Then it is driven through ironing rings. These rings squeeze the sidewall thinner as the cup moves through them. The metal does not simply get pulled longer. It is pressed and thinned in a controlled path, so the sidewall stretches upward while the bottom stays thicker. In seconds, the short cup becomes a tall open cylinder. The walls are now thin enough to save metal, but smooth enough to hold their shape. This is where the can finally starts to look familiar. The base is shaped next. A tool presses the bottom inward, forming the dome that can be seen under most beverage cans. This curve is not decorative. It helps the bottom handle pressure from carbonated drinks. A flat base would need more metal to resist the same force. The dome spreads that force through the bottom and gives the can strength without adding much weight. After forming, the top edge is rough and uneven. The can body is taller than needed, with tiny irregularities from the stretching process. A trimming machine spins the can and slices the rim to a uniform height. Thin rings of scrap metal fall away, while the cleaned edge moves forward. How does every can come out the same when the line is moving so fast? The answer is that every stage is guided by hard tooling, sensors, and repeated checks. If the height is wrong here, the can fail later when the lid is attached. The new cans now need to be cleaned. Forming oil, aluminum dust, and small residues still cling to the surface. The open bodies travel through long washing tunnels, often upside down, while sprays rinse them inside and outside. The wash removes anything that could ruin the coating or printing. After rinsing, the cans pass through hot drying tunnels. They leave clean, bright, and ready for decoration. Outside, printing happens while the can is still empty and open. Each can rolls against rotating print equipment that applies the artwork around the curved wall. Several colors can be laid down in close alignment, creating the familiar design seen on store shelves. A clean varnish is added over the print to protect it from scuffs, as cans rub against each other in machines, cartons, and delivery trucks. Once coated, the cans travel through an oven where heat cures the ink and varnish, so the outside finish becomes tough enough for handling. The inside now gets one of the most important hidden layers. A spray system coats the inner surface with a protective liner. Most people never see this step, but it is what keeps the beverage from sitting directly against bare aluminum. It helps protect flavor, prevents direct contact with the metal, and gives the inside a clean barrier. What stops the drink from touching the aluminum? This thin, even coating does. After spraying, the cans go through another oven so the liner cures into a durable surface. By now, each can is printed, coated, and shaped, but the top is still too wide. The opening must be reduced so it can accept a smaller lid. This saves material and creates the familiar shoulder near the top. The can moves through a necking machine, where a series of tools gradually squeezes the upper wall inward. The change is not made all at once. If the metal were forced inward too sharply, it could wrinkle or split. Instead, the shape changes in small steps, station after station, until the neck is narrow and even. Once the neck is formed, the rim is flanged. The top edge is curled outward into a small lip. Later, this lip will lock together with the lid during seaming. It is a tiny feature, but it carries a big responsibility. The whole seal depends on this rim being round, smooth, and consistent. A dent, split, or uneven flange could let liquid leak or gas escape. Before the empty can leaves the plant, it has to prove it is usable. Inspection systems check the height, wall shape, rim, print, and inside coating. Some machines use light to find pinholes or cracks. Others check pressure or airflow to catch leaks. Cameras look for damaged rims, bad printing, or dents. Rejected cans are pushed off the line and recycled. The good cans keep moving, now almost ready for the next factory. The can body is not the only part. Lids are made on a separate line, usually from a stronger aluminum alloy. Coils of lid stock are fed into presses that stamp round ends. Each end is shaped with a curled outer edge, a scored opening area, and a small raised rivet. The pull tab is made separately, then attached to that rivet. The scoring must be shallow enough to open when pulled, but strong enough to hold pressure until the customer opens it. Too deep and the lid could fail. Too shallow and the tab would not open cleanly. At the can plant, finished empty bodies are stacked in tall layers. Sheets separate each layer so the rims do not scrape or deform. The stacks are wrapped, covered, and placed on pallets. They are light, but they are still fragile from filling, because an empty thin wall can crush more easily than a filled one. Forklifts move the pallets into storage or onto trucks where they travel to beverage plants along with finished lids. At the filling plant, the empty can begins its final journey. The bodies are unloaded and fed back onto conveyors. They are often rinsed or blown clean before filling, because the inside has to be ready for the drink. The cans travel in tight rows toward the filler, where rotating heads lower into position. One can after another receives the beverage, with the fill level controlled so there is space left at the top. The lid is placed immediately after filling. A seaming machine brings the lid and flanged can body together. Rollers fold the two metal edges into a double seam, locking them into a tight seal. This is one of the most important final steps, because the can must hold liquid and gas through storage, transport, and handling. If the seam is weak, the product can leak. If it is too tight or badly formed, the metal can crack. The finished cans move past more checks. Machines confirm fill level, weight, seal condition, date coding, and package appearance. Samples may be opened to inspect the seam. Others are tested for pressure or leaks. The printed outside is checked so the can matches the brand design and the code is readable. Any can that fails is removed before it reaches a carton. Now the product is ready for packing. Cans are grouped into packs, wrapped in cardboard or film, loaded into trays, or packed into boxes. Cases move along conveyors toward palletizing machines, where they are stacked into stable loads. Stretch wrap tightens around each pallet, holding the cases together for warehouse storage and truck transport. From there, pallets leave the factory and move into distribution. The can may go to grocery stores, restaurants, vending machines, stadiums, or home shelves. By the time someone pulls one from a fridge, the long factory path is hidden behind a simple shape. A flat coil became a cup. The cup became a thin cylinder. The cylinder was washed, printed, coated, shaped, tested, filled, sealed, and packed. The final can looks effortless, but every curve, rim, coating, and seam was made to survive the journey from raw aluminum to the first sharp crack of the tab at the very first moment.